Right, in this video, we're going to talk about suggested homework problems from 10.4, polar coordinates and polar graphs. Let's go ahead and get started with number one. Consider the polar coordinate r theta. What does r represent? What does theta represent? R is the directed distance from the origin to the point on the plane. Theta is the directed angle. Counterclockwise is a positive orientation. Measuring the let's see, from the polar axis, that's the positive x-axis, to the line segment from the origin to the point in the polar plane. Well, either r or theta could be negative. We'd like them both to be positive when possible. That's just preference. So, but of the two, we mostly prefer a positive r and really don't care about negative theta values. We just will make our angle go clockwise instead of counterclockwise. So try to stay away from negative r values unless you're told to do so by the problem. So comparing coordinate systems, describe the differences between rectangular coordinate system and the polar coordinate system. So the rectangular coordinate system this is the Cartesian. Has a unique representation x, y for every point on the plane. X measures the distance from the y-axis to the point. And y measures the distance. This would be a directed distance. the x-axis equals 0 to the point on the plane. We've already defined the components of the polar coordinate system. The polar coordinate system is a collection of points r theta with r and theta as defined in problem number 1. Polar representations of points are not unique. There are infinitely many ways to represent the same point with a positive r value or with a negative r value, just by going around either 360 or 180 degrees, and making coterminal angles with that. So those are the big concepts there. Let's go ahead and look at number 9, which asks us to plot this point in the polar system, given this r theta, and then to convert it to rectangular, knowing that x is equal to r cosine of theta, y is equal to r sine theta. You'll also want to know that r squared is equal to x squared plus y squared, and that tangent of theta is equal to y over x. Those are all important conversion factors for you to know. We're facing in the direction of 5 pi over 4, so we're on this ray here somewhere, and we're a distance of 7. So 1, 2, 3, 4, 5, 6, 7 is right there is our point, 7, 5 pi over 4. If we look at this now with our right triangle trigonometry, what are our x and y components? If this side, the hypotenuse here is 7, then x is to 1 as 7 is to square root of 2. So x is equal to 7 root 2 over 2 when I rationalize this, but I need this to be a negative 7 root 2 over 2 since I'm going to the left. And this is a isosceles right triangle, so this is also 7 root 2 over 2 negative. So the rectangular point for this will be negative 7 root 2 over 2, negative 7 root 2 over 2. Let's go ahead and look at number 23. Using those same conversion factors, let's look at the rectangular point for 5 and change it to a polar r theta using x squared plus y squared is equal to r squared. 4 squared plus 5 squared is equal to r squared. 16 plus 25 is r squared. R squared is 31. R is root 31. Remember, I told you to make sure that you use positive r values whenever possible. Tan theta is equal to y over x. So theta is arctangent of 5 fourths. And we are in quadrant 1. So that's fine. I don't need to add pi to that. Sometimes I need to add pi to my angle if I'm in a quadrant other than where arctan returns its values. Remember that it returns negative angles for uh, quadrant 4. I need to add 2 pi to that, or pi, depending on if I'm in quadrant 2 or 4. It returns positive values for quadrant 1. If I need quadrant 3, I'll need to add pi to that. So my polar version of this point is root 31 arctangent of 5/4. Exactly, you can get a decimal approximation in radians for arctangent of 5/4. Let's go ahead and look at number 27. We have a rectangular equation here. X squared plus y squared is equal to a squared, where a is a constant. And we want to change that into polar form, where x squared plus y squared is r squared. If r squared is a squared, r is a. And that's the equation of a circle of radius a. And I'll try my best to draw this without a compass. It's really not a great circle. Let's see. This can draw shapes for me. Circle. There we go. Circle of radius a. That's what I want. So let's do 33. Y squared is equal to 9x. So y is equal to r sine theta. So this is r squared sine theta. 9 and x is r cosine theta. So I would like to divide by r here, and then divide by sine here to solve for r. So r is equal to 9. Cosine over sine is squared, squared, squared. So this is going to be cosecant theta, cotangent theta, right? Yes. So what would that look like? That is going to be, well, we know what it looks like from rectangular. It's got its vertex at 0, 0. It opens to the right when x is 1, y is plus or minus 3. And it's exactly the same conic section, whether I represent it in rectangular form or polar form. It's still this parabola that's opening right. Let's see if I can do this in mode polar, and y equals 9 cosine of theta divided by sine of theta squared, because there's yeah, and then that's going to be zoom 6, and there it is in polar form. All right, let's look at 41. R is equal to 3 secant theta. So converting this back into rectangular would give me r cosine of theta is equal to 3, which is x is equal to 3. So that's 1, 2, 3. We have this vertical line. I want to see that vertical line in polar form, 3 divided by cosine of theta graph, and there's the vertical line x equals 3 in polar form. Let's look at 63. Has the polar equation r is equal to 2 times 1 minus sine theta. We want to find the slope of the tangent line dy dx for the given points, and the given points are r theta, and we want dy dx. So this is 2, 0, 3, 7 pi over 6, and 4, 3 pi over 2. So dy dx has a, we'll call this f of theta, is 2 minus 2 sine of theta. F prime of theta is a negative 2 cosine of theta. A dy dx is equal to f of theta cosine of theta plus f prime of theta sine of theta over a negative f of theta sine of theta plus f prime of theta cosine of theta. So dy dx will be 2 minus 2 sine theta times cosine of theta minus 2 cosine of theta times sine of theta over a negative 2 minus 2 sine of theta cosine of theta plus a negative 2 cosine of theta squared. And that's going to be dy dx is 2 cosine of theta minus 2 sine theta cosine of theta minus 2 sine theta cosine of theta over a negative 2 plus 2 negative 2 cosine of theta plus 2 sine theta cosine of theta minus 2 cosine squared theta. It's the sine, not cosine. So it's wrong here. 2 sine and plus 2 sine squared. That looks better to me. And dy dx is, let's see, 2 cosine minus 4 sine cosine over 2 sine squared minus 2 sine minus 2 plus 2 sine squared. is 4 sine squared minus 2 sine minus 2. These are all even, so might as well take the 2 out of everything to simplify. Is cosine minus 2 sine cosine. I don't want to use a double angle identity and make things harder here. 2 sine squared minus sine minus 1. And I can factor here cosine times 1 minus 2 sine over 2 sine theta, and that's sine theta, and I want a minus 1 and a plus 1. So now let's look at those points again. Our theta dy dx that I want to find were 2, 0, 3, 7 pi over 6, and 4, 3 pi over 2. So notice that there is no r left in any of this. Dy dx, I could have used r, but I didn't. That would have made things nice. R is 2 times 1 minus sine theta. So I could have done that, but I didn't. So anyways, let's look at when theta is 0. It's going to be 1 times 1 minus 0 over 0 plus 1 times 0 minus 1. It's going to be 1 over negative 1 is a negative 1. And slope, okay? And then dy dx at theta equals to 7 pi over 6. We should see that's a vertical line. The slope should be undefined. So cosine of 7 pi over 6 is a negative root 3 over 2. One minus 2 times a negative 1/2 over 2 times a negative 1/2 plus 1 and negative 1/2 minus 1. Well, this is a negative 1 plus 1 is 0 times anything is 0. This is 1 plus 1 is 2. This is negative root 3 over 0 is undefined, which makes sense. Look at that slope. And this slope is negative. That makes sense to me. Dy dx at theta equals to 3 pi over 2 is cosine of 3 pi over 2 is 0 times 1 minus 2 times a negative 1 plus 2 over negative 2 plus 1. Doesn't really matter any of this. Negative 1 minus 1 is, this is all 0 over 2. So what it looks like is 0. And that's exactly what that looks like. Now let's come here, 2 times 1 minus sine of theta, zoom 6, and then second calc, dy dx, when we are at theta equal to 0 is -1. Second calc, dy dx when theta is equal to 7 pi over 6 is, there's our it's a really big negative number. It's negative infinity. It can't calculate it. It can't represent negative infinity and say error, but look at that it says times 10 to the 8th. It's a huge number. So don't trust the calculator to give you infinity or negative infinity. At 3 pi over 2 is 0, and that's good. Okay. Just want to show you that the calculator can help you get that and check your answers. I believe we're on 69 next. Yes, so horizontal and vertical tangency, r is equal to 1 minus sine theta. So we want where, let's find d r d or dy d theta is the numerator part of what I showed you before. That would be equal to f of theta cosine of theta plus f prime of theta sine of theta, and dx d theta is the bottom part of what I showed you before, the negative f of theta sine of theta plus f prime of theta cosine of theta. And I want horizontal tangent lines are when dy d theta equals 0, but dx d theta is not equal to 0. Vertical tangent lines are when dx d theta is equal to 0, but dy d theta is not equal to 0. So let's go ahead and find if this is f of theta, f prime of theta is equal to a negative cosine of theta. So dy d theta is equal to 1 minus sine theta cosine of theta plus a negative cosine of theta times sine of theta. Our dx d theta will be a negative 1 minus sine theta times sine theta plus a negative cosine theta times cosine theta. So that will be cosine squared. Dy d theta is cosine theta minus sine theta cosine theta minus sine theta cosine theta. Dx d theta is a negative sine theta plus sine squared theta minus cosine squared theta. Dx d theta is equal to 2 sine squared theta minus sine theta minus 1. This is dy d theta is cosine of theta minus 2 sine theta cosine of theta. Going to set these equal to 0 and solve. So cosine of theta times 1 minus 2 sine of theta is equal to 0. And then this one is 2 sine of theta minus 1 plus 1 equals 0. cosine of theta equals 0, or sine of theta equals 1/2, sine of theta equals -1/2, or sine theta equals 1. Cosine of theta is 0 and we're only going to around the first revolution here. So theta equals pi over 2 or 3 pi over 2. Sine is a positive 1/2 at pi over 6 or 5 pi over 6. Over here, theta is equal to sine is 1 at pi over 2, -1/2 at 7 pi over 6, or 11 pi over 6. Pi over 2 shows up in both lists, cross it off. So then we have dy dx at, let's see, which one do I find first? At I've got the angle, I just need the r. So r of pi over 6 is 1 minus sine of pi over 6, 1 minus 1/2, equals 1/2. So that gives me a point here of 1/2 pi over 6. R of 5 pi over 6 is 1 minus sine of 5 pi over 6 is also 1/2. It's also 1/2, so that gives me 1/2 5 pi over 6. R of 3 pi over 2 gives me 1 minus the sine value of -1 equals 2. So that gives me the point here, 2, 3 pi over 2. Those are all my points of horizontal tangency. For vertical tangency, I have r of 7 pi over 6 is 1 minus a -1/2 is 3/2. So that will give me 3/2 7 pi over 6, and r of 11 pi over 6 is also 1 minus a -1/2 is also 3/2. So that's 3/2 11 pi over 6. And those are my points of vertical tangency. Let's look at number 73. For the equation, r is equal to 5 sine of theta. Sketch the graph of the polar equation and find the tangent lines at the pole, if there are any. So this is r squared is equal to 5r sine theta. X squared plus y squared is equal to 5y. X squared plus y squared minus 5y equals 0. Half of the middle number squared. 25/4 is x squared plus y minus 5/2 squared equals 5/2 squared is a circle centered at 0, 5/2, 2.5, 3, 4, 5, and then it'll sit right there, and then 1, 2.5 here, and 1, 2.5 right there. And again, not best at drawing circles freehand. There's my best attempt at that. At r is equal to 5 sine of theta. We're interested in this tangent line right here, which is the polar equation theta is equal to 0. Let's go ahead and look at number, is that 85? R equals 3 minus 2 cosine of theta. And we want to sketch a graph of this. Again, not the best at drawing these, but try. So using some values that I know will work nicely here. Cosine of 0 is 1, so 3 minus 2 times 1 is 3 minus 2 is 1. So I have 1, and then at pi over 3, cosine is 1/2, so that's 3 minus 1 is 2. So along this line right here, I'm going out 1, 2, and then at pi over 2, cosine is 0, so that's 1, 2, 3, and then along this line of 2 pi over 3, cosine is a negative 1/2, so that's going to be 3 plus 1 is 4, so 1, 2, 3, 4, and then at pi, cosine is going to be negative 1, that's 3 plus 2 is 5, 1, 2, 3, 4, 5. So I should get a shape that looks something like this. I'm going to go out and come back a little bit. It has kind of this, it's called a limacon, L-I-M-A, and then the L-I-M-A-C-O-N, limacon. And this is going to be symmetric to the polar axis here. So if I have the bottom half of this comes out and then back in the same way. Again, I'm freehanding this, so don't expect this to look wonderful. I'm going to put it in my calculator here in just a second, but it's something like this. And then let's let the calculator graph it just so you can see 3 minus 2 cosine of theta, zoom 6 for polar, and there it is. It looks something like that. It's got this little dimple in it there, which is what I was trying to show you here, that it's got this little dimple. All right, that's it for this video. We'll come back next time and talk about suggested homework problems from 10.5, where we'll be talking about area and arc length in polar coordinates. So see you next time for suggested homework problems for 10.5.